All right. Okay. So I'm gonna start this by talking about what we did on Tuesday, which is balancing equations. And I know they're kind of confusing, which is a-okay. You know, nothing's gonna be easy, especially in chemistry. So you have to kind of give yourself just a little bit of hope or faith. Alrighty. So let's start out with this equation. I chose this equation because kind of, in a sense, it's easy to kind of, I guess, to explain. I'm going to try my best. I know it's not going to be perfect, but I'm going to try. But yeah, so just something I would also like to point out is if you kind of have trouble seeing how the equation looks, like you don't recognize the values of each of these, like how many is in the actual chemical formula here on this half at least, then the best thing to do is to write out the numbers and how many is in per each, and then go from there. So on this side, we have 1 potassium, because there's no number, or no number in front, or no number here. So 1. We have hydroxide, which is 1, because there's, again, no number here, no number anywhere. It's just the element as itself. And we have 1 iron. Again, same situation, but we have 3 nitric acids. So that's 3. So we're going to work with this. Keep in mind, some compounds do have not an accent or like a subscript sort of number at the bottom, because that's also indicating how many oxygens are in a nitrate, or however that works, you know, in a sense of. So now we need to go and look at what things bond, which again would be us balancing on this side, right? So I know the best way I can explain it, and the best way it's worked out for me, is I have, in a sense, I recognize that, which, just so you know, if you need to know, an ionic bond, which is, this is important, is when two strong charges plus or minus come together. That's like an elementary way of explaining it. It's not the best, but it's something. So that's kind of where I'm going to start at. What time am I? Okay. I'm not too bad on time so far. All right. Just trying to think. And I'm trying to talk slow, which is causing me to like deeply breathe. Because you know me, I'm always talking fast and always thinking fast. So I'm like excited here. But anyways, let's take this slow. Okay. So we have potassium, hydroxide, iron, and nitrate, right? So we can try a few things first. We could do, like I had done here, OH bonding with NO to the third, hydroxide bonding with nitrate. I don't think that works because nitrate's, for one, already oxidized, in a sense of yes, because it's, you know, nitric acid. And 2, their charges are different. So nitric acid has a -1 charge, and hydroxide has a -1 charge as well, meaning they cannot bond together for an ionic bond. So we're going to just dismiss those as not being a pair. Instead, let's try iron and OH. So iron oxide. Or no, I'm sorry, iron hydroxide. So what you're going to do is, because this to me just looks weird, so I just like naturally threw it in parentheses. I don't know. This is also could just be because it's my, coming out in me. My sense of, my sense of being in math, and just like, oh, you know, parentheses are perfect, let's use parentheses. So again, that could be it as well. Who knows? But so we have this to start out with, and the reason why these two bond, in a sense, this is the whole reason why these two bond, is again, they have different charges. This has a +2, iron has a +2 +3 charge, as for hydroxide has a -1 charge, therefore giving them like a good little bond. Yeah, they're my fingers. So we can add those on one side. The next side is going to be potassium and nitric acid. The reason why I threw potassium on this side with nitric acid is, for one, they also bond. Nitric acid has nitric acid has a charge of -1, and potassium has a charge of 1 +1. Therefore, those have a ionic bond, so those are going to bond. And not only that, but I believe this one is the one that forms a precipitate. I'm not too sure. Don't quote me on it. Oh, I should probably write these in. So this formula here is aqueous. So aqueous, in a sense, is kind of like acid, I believe. It's a different substance than liquid, but in chemistry, it's acid. I believe this is also acid as well. It is. All right, now we have this to work with. So to balance it, let me just move these numbers over here. So 1, 1, 1, and 3. This is not balanced at all. Well, no, wait. No, hold on. Let me get rid of these. Looking at this compared to this is not balanced at all. You don't have 3 nitric acids and you have 1 of each on here, but how's that gonna work, you know? Because you need, hold on. Like well, for one, this is fine because these two are bonded correctly, but how is it gonna work? Because we have 3 nitric acids, the rest are 1, so they're all fine, but we have 3. How are we gonna be able to distribute those, right? So, in a sense, oh, I didn't mean to knock that if I did. I think, so there's 3, oh wait. Oh shit, I forgot to, hold on. How did I write it? Oh, so in a sense you have to think of this as like 3, right? This already has 3. This has 1, 1, and 1. So, you gotta think to yourself, okay, so if I put 3 right here, instead of brandishing that off and putting it down there, what's that gonna give me? What do I have to do? So you multiply 3 on this side, which, keep in mind, goes for both. So what you're going to do is you're going to throw a 3 right over here. And then you can see it's balanced with the potassiums, because you have 3 potassiums on this side and you have 3 potassiums on this side. Uh-oh, I found an issue. Now this would mean that there is 3 hydroxides. So what you're going to have to do is throw a 3 right down here. Which again, that's also why the parentheses comes in handy, because it just is like, oh. In chemistry, anything that you put in the parentheses or to the power of, like in a sense, if it was Fe to the 2, that means there's 2 Fe's in one molecule or in one equation. So in a sense, the same situation is happening here with the OH or the hydroxide. Hopefully I'm not talking too fast. But yeah, let me explain this a little bit slower. Again, if we have 1 potassium on this side, 1 potassium on this side, that would be balanced. Issue is we have 1 nitric acid. So throw that 3 right in front of the K and throw it on front of this side. Uh-oh, I have hydroxide. That's being multiplied by 3. Now there's 3 hydroxides. So you throw that 3 right down here and that's balanced. So, yeah. Again, what I like to do is I like to highlight, well, no, I want a different color. Like to highlight what the change was. So 3 here, 3 here, and 3 here. So what you're gonna do now is show, you can kind of, if you want to, you can show the work. So 3 equals 3 times 3 equals 3 times 3 equals 3. There's 1 iron throughout the whole thing, so you don't have to worry about iron. Times 3 equals 3. Now it's balanced. All right. Next, I'm going to go on to the complete ionic and net ionic equations.